Modern processor architecture explained, from smartphones to computers. Processors, often referred to as the brains of electronic devices, are marvels of modern engineering. Their operation, whether in a smartphone or a computer, is based on the same fundamental principles, though their design philosophy differs significantly. A smartphone processor must prioritize extreme energy efficiency for battery life, while a desktop processor is designed for raw high performance. The core components and their even at the heart of every processor are billions of microscopic transistors. These are electronic switches, much like a light switch, but operating millions of times per second. Their on-1 and off-0 states form the binary language of all computing. A processor's power is often indicated by its clock speed, for example. 26 GHz, which signifies how many billions of these on-off cycles instructions it can execute per second. However, a higher clock speed alone doesn't guarantee overall performance. It's like comparing the speed of a single worker to the efficiency of an entire team. This is where processor cores come in. Think of cores as individual rooms in a house, each capable of handling a separate task. A dual-core processor has 2 such rooms. A quad-core has 4, and modern processors can have 8 or even 16 cores. This allows for true multitasking. One core can handle a phone call, another can run a messaging app, and a third can play music simultaneously. Smarter processing, heterogeneous architecture, and threading. To balance power and efficiency, modern smartphone processors like those from Qualcomm, Apple, or MediaTek use a heterogeneous core design. This means not all cores are the same. High-performance cores, big cores. These are larger, more powerful cores designed for demanding tasks like gaming, video editing, or intensive apps. They consume more power. Efficiency cores, little cores. These are smaller, slower cores that handle routine background tasks, like receiving notifications, playing music, or managing sensors. They sip battery power. The processor intelligently distributes tasks, using efficiency cores for light work and firing up the high-performance cores only when needed. This is why today's smartphones can offer both high performance and good battery backup. Another key technology is threading. For example, Intel's This creates virtual cores, allowing a single physical core to handle 2 instruction threads at once. It's like one person efficiently juggling 2 related tasks, sharing their focus based on priority. A dual-core processor with threading can function like a quad-core system for many tasks, significantly improving multitasking. Generations and fabrication. The shrinking transistor processor technology advances in generations. Companies like Intel Core i3, i5, i7, i9, and AMD Ryzen 3, 5, 7, 9 release new series when they make major architectural changes. Within a series, smaller annual improvements lead to new generations. For example, 11th gen, 12th gen. Similarly, Apple has progressed from the S-series to the M-series chips. A critical metric is the fabrication process measured in nanometers. Nanometer, for example, 5 nanometers, 7 nanometers. This number refers to the size of and distance between transistors. A smaller NM process allows more transistors to be packed into the same space, making the processor faster, more powerful, and significantly more energy efficient. For example, Apple's A15 Bionic and Qualcomm's latest Snapdragon chips use a 5 nanometers process. More than just the CPU. The main processor chip in a device, especially in smartphones, is a system-on-a-chip, so it integrates multiple specialized blocks beyond the central processing unit CPU cores. GPU graphics processing unit handles all visuals rendering the user interface, videos, and complex game graphics. Cache memory, a small, ultra-fast memory located very close to the CPU cores. It stores frequently needed instructions and data to drastically speed up processing. Modem manages all cellular network connectivity for calls, texts, and mobile data. Memory controller acts as the bridge and traffic manager between the CPU and the device's main RAM. ISP image signal processor, a specialized unit dedicated to processing photos and videos from the camera. It performs tasks like noise reduction, color correction, and pixel mapping in multiple steps, all in milliseconds. DSP, digital signal processor, processes digital signals from components like microphones, speakers, and various sensors. storage controller manages reading from and writing to the device's internal storage, for example, UFS NVMe. How it all works together. The data highway. These components are interconnected by an advanced network-on-chip node, a complex web of microscopic wires and routers. This network acts like a super-efficient multi-lane highway system with smart traffic lights, routers, and switches, ensuring data gets from one block like the ISP to another like the GPU quickly and without congestion. Putting it into practice, taking a photo. When you click a photo on your smartphone, the camera sensor captures raw pixel data, millions of points of light and color information. This massive data is sent to the RAM and then immediately to the ISP. The ISP processes the raw image in multiple steps, fixing imperfections, enhancing details, adjusting colors, and compressing the file. The processed image data is then handed off to the GPU, which prepares it for the display's resolution and format. Finally, the display engine takes this data and renders the final photo you see on your screen all in a fraction of a second. Conclusion: the symphony on a chip. The modern processor is a symphony of specialized components, transistors, caches, and accelerators, all working in perfect harmony on a piece of silicon smaller than a fingernail. Understanding terms like cores, clock speed, fabrication, process, nanometer, and heterogeneous architecture empowers you to make informed choices, focusing on the quality and efficiency that truly matter in your devices. This incredible integration of technology is what powers our digital world, enabling everything from simple texts to complex augmented reality. If this explanation resonated with you, please like, share, and comment below with your thoughts. Your engagement encourages the creation of more content like this. Thank you for reading.